Chapter 4 is about chemical reactions and chemical quantities. And here's a quote from Linus Pauling, who's a very famous American chemist. I feel sorry for people who don't know anything about chemistry. They are missing an important source of happiness. I'm sure most chemistry students would not agree with that statement, but it is what it is. So, anybody heard of global warming? It's a really big deal right now. What is global warming? Why does carbon dioxide or your carbon footprint matter? Well, how does the Earth stay warm in the first place? So here we have an illustration of the Earth, and we have atmosphere. And the atmosphere here is called greenhouse gases because that atmosphere acts like the glass of a greenhouse, right? A greenhouse stays warmer than the outside because the sun comes through the glass and warms what's inside, but that keeps all the warm air from blowing away. And so you can raise plants that are sensitive to frost in very cold places using a greenhouse. So what happens is the sunlight passes through the atmosphere and it warms up the surface of the Earth, and then some of that heat will escape, but a lot of it is trapped, bounces back. It's trapped on the surface by greenhouse gases. Now, greenhouse gases are really important because if we didn't have any greenhouse gases, it would be so cold that no life could exist, right? And actually, the temperature, the average temperature of the Earth, we don't want it getting too warm, but getting too cold is bad as well because that can trigger an ice age, which isn't good either. So it's the balance of ingoing and outgoing energy that keeps the Earth warm but not too warm. So as of the writing of this book, scientists had measured an average 0.7 degrees Celsius rise in atmospheric temperature since 1860. So here we see a graph of that. This is the temperature. So here's the temperature deviation from average. And the baseline used was 1951 to 2010. And so, this is before that time period, and so it was cooler. And here's the baseline part. And then it's gone up fairly dramatically. And so just like with the COVID cases, we see changes every year, but then the red line is a 5-year average. Because the temperature can change significantly from year to year. We'll get a cold year, a warm year, etc. During this same time period, we've also seen the atmospheric CO2 levels have risen. They've gone up about 38%. So a big question is, are those two trends causal? Meaning, is the increase in carbon dioxide causing the increase in temperature? Or are they just happening together, right? Well, I think we can say that the carbon dioxide increase definitely has something to do with the increase in temperature. How could we start to look at where is this CO2 coming from? Well, of course, one important source is combustion reactions of fossil fuels. So I drove here, shame on me, in a gasoline-powered car, and it generates carbon dioxide as it burns the gasoline. Many of our electric plants are fueled with various fossil fuels. Coal is a fossil fuel. Even natural gas will give off, anything you're burning is going to give off CO2. But there are also natural sources of CO2, and one of those is volcanic action. So, maybe all that CO2 is just from volcanoes, right? How could we even figure that out? Well, in order to figure out just an estimate of how much CO2 is being put into the atmosphere from combustion, we need to look at the chemical equation that describes how fossil fuels burn and how that relates the amount of fuel burned to the amount of carbon dioxide released.